So in this video we're going to calculate voltages at different nodes in a resistor circuit. I have two resistors here, R1 and R2. Both are 100 ohms, and I have a current source I1 which is 1 amps, as you can see here, and I've named the two nodes as 1 and 2. So the voltage at 1 would be V is equal to IR by Ohm's law. So my current is 1 amps and there are two resistors here, so that would be 200, adding both the resistors. So if I measure the voltage here, so that is 200 volts as expected, and the voltage at the middle node should be 100 because there is R2 resistor, only one resistor is connected at that end. I'll change the color of this to red so that it's visible. So on the bottom of the screen you can see that the voltage at V2 is 100. So if I add another resistor, it is R, and that would be also 100. Similarly, we can do the same. We could name this as node 3, and we could again run the simulation. So it would be at P1, that's the green, that's 300, and the voltage at node 2 is 200, and the voltage at node 3 should be 100. So that is the blue one. I'll again change the blue one to something visible. Let's try this yellow. So yes, so V3 here is 100. So I have now replaced the current source with the voltage source. So 9 volt supply, and everything else is the same. So if we measure the voltage here again, running the simulation again, at 1 it should be 9 volts, that is expected, and at 2 it should be half of 9 volts because we have R1 and R2 is equal. And with the formula R2 divided by R1 plus R2, we get the voltage at V2 as 4.5 volts. So again, if that's 4.5 volts at the bottom, and again if I add another resistor, and let's again calculate the voltages at these nodes. I'll name this as node 3, and if I run the simulation again, I should get that's 9 volts here and 6 volts here and 3 volts there. That's because 3 resistors are connected. So similarly, you can build the circuit that we did in class, the resistor cube, and we can measure the voltages at different nodes.